Hi, I'm Laura. I will be speaking about the metadata of image acquisition. In this RDMbite, you will learn about the image acquisition module of REMBI metadata. You will learn about the metadata that should be collected to describe the method of image acquisition and how to store it. Image acquisition metadata is all the information about the instrument you have used and how it was set up. Like with the specimen metadata, describe this information as though you are speaking to someone who already knows how to use a similar instrument. What would they need to know to produce the same image data? Start with the details of the equipment for the instrument attributes. If this is commercial equipment, include the make and model, a short description of what type of instrument it is, and details about its configuration. If the instrument is bespoke, you will need to include more details. Next, you should include image acquisition parameters. These relate to how the instrument was set up for the particular experiment. Some of these can be captured automatically by the instrument software, so make things easy for yourself and check if a file is generated and what's in it. If a file is generated, then you only need to manually record anything that is missing from that file. It's difficult to say exactly what parameters you need to record, as these will vary depending on the instrument. Check with your facility management if they have any guidelines for what details need to be recorded for your particular instrument. For example, my facility at Warwick has a web page with a checklist for light microscopes, as well as details for the microscopes we manage. You can also look for papers relevant to your field for methods of reporting or minimum information standards. Make sure that the parameters you record can actually be used by someone else if they don't have exactly the same instrument or setup. For example, don't say that you used a certain percentage of laser power, as this doesn't tell you how much power was used, unless you also provide the total power of the laser. Here is an example for confocal microscopy. The instrument used is an Olympus FV3000, which is a laser point scanning confocal. It has a 500 to 550 nanometer filter and a 37-degree chamber. It can be a bit unclear what should be counted as an attribute and what should be counted as an acquisition parameter. As long as the details are recorded, don't worry too much about the category. The acquisition parameters have details relevant to confocal microscopy. Remember to include units for relevant values. Once you have collated all the metadata from image acquisition, you will need to store it. If the instrument software has automatically generated a metadata file, remember to save this. Depending on its content, this may be sufficient, or you may want to copy the relevant details to another file if it contains a lot of information that you don't think is relevant or does not have all the information you require. Otherwise, you can add these details to the file where you are storing your biosample and specimen metadata. Remember not to create new sheets if you are using a spreadsheet software, but simply continue the table. This will keep all the relevant metadata together, and storing them in the same directory as the data will make it easy to find. Please see links to additional resources alongside this video, as well as other RDMbites in this series.